Good morning, everyone. Welcome to the Indian origin of the sine. When people think of the history of mathematics, they mostly think of Western or European inventions and discoveries. It's super easy to forget India's massive contribution to modern mathematics, which includes the two most important trigonometric functions, the sine and the cosine. The first function in Indian mathematics that relates to the modern sine is jya, literally meaning bowstring. This first appeared in the Surya Siddhanta, or Sun Treatise, an Indian mathematic text from the latter half of the first millennium AD. The sine originated as an analogy to archery. Think of a bow, which is like the circumference of a circle. You have a bowstring, which is vertical, and it recoils back when it's stretched. So instead of forming a right angle to the arrow, which is the adjacent side of the triangle, it now forms an acute angle, which is theta. Remember that sine is equal to the opposite side divided by the hypotenuse sine of the angle theta. Here is the specific terminology they used. Jya specifically refers to the chord or the whole bowstring from B through E down to C. Jyarda specifically refers to half of this, or the opposite side to the angle theta, BE. And of course, this, when divided by Vyasarda, or the radius, BA, gives the sine. They wanted to find out how long Jyarda was for a given value of theta, or how far you stretch the bowstring back. This led to the development of not just the sine function, but also sine theta values and tables. The Indian mathematician Brahmagupta, who lived in the 7th century CE, was known for this sine table, which Amaraja would explain 500 years later. Take a circle whose circumference is divided into 12 equal segments of 30 degrees, or sines. This circle has a radius of 150 units. We know that sine of 30 degrees is half of the radius, or 75. If you go to the other side, you see this green triangle that's 60 degrees. The adjacent side is 75, or half the radius, and the hypotenuse, or the radius, is 150. So obviously, by doing Pythagoras' theorem, we can find the length of the opposite side. With this blue triangle, and reflecting it downwards to create a right triangle, we can find the sine for 45 degrees, and we can continue doing similar things to create the rest of the sine table. Finally, the Indian sine reached Europe through the Islamic world in its translation movement in the latter first millennium AD. The translation sequence is there below. Thanks for listening.